Hey guys, I'm Sammy and I am back looking to do some technical interview preparations. So this is going to be my first LeetCode problem. It's LeetCode number 1, two-sum. It's an easy problem. It's dealing with arrays, and the main gist of it is basically that given an array of integers, nums, and an integer target value, return the indices of the two numbers such that they add up to the target. We can assume that each input would have exactly one solution, and we may not use the same element twice. And we can return the answer in any order. So just to kind of like take care or analyze that small edge case, we can kind of look, we can compare examples 1 and 3, for example. So if you look at example 1, we got nums as 2, 7, 11, 15, and the target 9, and the output expected is 0, 1. Meaning that the elements at indices 0 and 1, if they're added together, they'll get us the target. So clearly 2 plus 7 equals 9. Corresponding index values are 0 and 1. Now if we look at example 3, we have nums with two elements. They're both 3. We're looking for a target 6. However, even though they're both 3, they are distinct because they're at different index locations. So I'll just jot down some like pseudocode or just kind of like an initial intuition of what we want to do here. There is a brute force algorithm, approach. It's possible, but it's going to be like O(n) squared time, where we basically check each pair of values possible in nums, and that's just like no. So what we can do is we can actually use a faster approach, something a little more efficient, using a hash map. So we can start off by saying that if I have this hash map, we'll name it nums map, sorry, and it'll contain an int as a key value pair. And so the key that we'll store is going to be an element of nums, with nums of I, and the corresponding value that we'll store will be I as the index that we're at. So the intuition is that we loop through nums, okay, and at each iteration we'll compute the complement. So the complement will simply be this value, which will be equal to the target minus the current element at nums of I. And so this expression will tell us that, hey, if I'm at, for example, nums of 0 as the first iteration of the loop, in example 1, nums of 0 is 2 and the target is 9. So the complement will be 7, which is 9 minus 2. And this basically tells us that, hey, if I'm at, index 0 in nums and the element is 2, I need to look for the value 7 in the nums list to be able to, get two indices that will equal the target. So after we compute the complement, we'll do a check. We'll see check if the complement, I'll just abbreviate with comp, is in nums map. And we got to make another check here that we want to confirm that the corresponding index, so the key value, the value of nums of map of complement, if it exists, right? So whatever index is associated with complement, we want to make sure it's not equal to the current I that we're looking through, because we want two distinct. The element, we cannot use the same element twice. So even if they have the same value, they have to be at different indices. So that's how the distinction works, and that's how we'll check for this edge case. So if the complement is in nums map and the index stored with the complement is not the same as I, we can basically return our two new indices as I and nums map comp. Okay, and if this is not the case, so like if this is not true, we'll come down, I will simply place nums of I, comma I into nums map. And that's pretty much the algorithm here. You can see clearly it's not a brute force approach. We only loop through the nums array at most like O of n times, so just at most the number of elements in the list. So I think we can go on to pretty much coding this out. Should be fun. So let's go ahead and code this solution out in Java. So start with I'll use a HashMap. HashMap storing an integer key value pair. We'll call it numsMap, like such. And so we'll iterate through nums starting at 0 until nums.length. And we'll compute the complement at each iteration as the target minus nums of I. Then we'll check that, hey, does this complement already exist in our nums map? And is its corresponding value different than the current I that we're at? So we'll say if nums map dot contains key complement and nums map dot get complement does not equal I, then we can simply return a new integer array using I as one index value and nums map dot get complement for the corresponding index which the complement is stored at. And if that is not the case, we'll simply just say numsMap dot put. We'll put nums of I in there, so we can keep looping and adding elements to the hash map, and we'll store the corresponding index. And if this is not the case, we'll just return null at the end. So let's give this a shot, see if it's working. Accepted. Case 2 was also accepted. Case 3 was also accepted. So let's go for that submit. Okay, runtime 2 milliseconds, memory 43.86 megabytes, and yeah, we beat about 23.62% of users that are coding in Java. So yeah, thanks for watching, and I'll be posting more LeetCode solutions as I do more problems. But yeah, it's not bad. Take care, guys.